Hello students, in this video lecture I will cover up some basic concept of the process synchronization. So firstly we should go through the process. What is process? As we know that process is a program in execution. When a program brings up from the secondary device to the primary memory and handed over to the processor, then it becomes the process. So process may be independent or may be cooperative. There are two types of the process. These are so independent process. Independent process are those which are neither affected or nor affects the any other process. Means run separately. There is no common part. For example, if I am executing a C program of Fibonacci and a C program of factorial, both are independent, they are not sharing any variables, anything, so they are the dependent process. Cooperating process are those processes which are sharing something, means there is a transfer of some data from one process to another process, so those processes are the known as the cooperating process. Now process may be categorized as concurrent and parallel, or we can say the execution of the process may be the concurrent or parallel. If I am executing a word file, writing something on a word file, I am listening the song, I am copying a file. So there are three tasks. So these tasks, execution of these tasks is known as the concurrent. Because as we know that the processor can perform one task at a time. So after certain time of interval, the processor switch overs from one process to the another process. Such type of shifting or change of execution from one process to another process is known as the concurrent execution. While in case of parallel execution, the computer have number number of processors that execute the task simultaneously. If each processor is assigned a task and that execute independently, this may be possible. Now, cooperating process that are those processes that are affected by or affect some process is known as the cooperating process. Cooperating process basically shares the logical address space. Logical address space means there is a space, memory space. This is the OS, and there are some space that will be shared by more than one process. That may be P. This is the process P1. This is the process P2, and both are sharing the same space. So there are two methods of sharing of variable. First one is the shared memory as it is, and second one is the message passing. So for this there is a foundation of buffer. Buffer should be of limited size. Now here I am taking an example. What is the basically race condition? How critical section can be critical section problem creates, and how can we resolve the critical section problem? Suppose that there are two process. First one is the producer process and second one is the consumer process. The producer process is incrementing the value and consumer process is the decrementing of the value. Here the counter will have some predefined value, let it is 10. Now if this is the independent process, then P1 will increase the value, then it will become 11, and then after the consumer will decrease the value and this will become 10. So answer will remain 10. But if the variable is shared, this variable is shared and these processes are using or we can say accessing the variable simultaneously, then what will be the problem arise? So here, when the process P1 copies the value of the counter from the memory location MX to the register. This register is known as the accumulator. So it will store the value of location MX into the register, and then after the register value, that means accumulator value will be get incremented by 1. AC is equal to AC plus 1, and then after, once the accumulators has computed the value, it must be stored that particular memory location MX. Now what happens here? Well, when the process P1 was incrementing the value, before updating the value, the processor switch over from process P1 to P2. Now the value that the process P2 will read is still 10, because P2 P1 process has not updated the value. It has computed, and still the value is in the accumulator. It has not reflected at the memory location. So at the memory location, value is still 10. The P2 will read the value 10 from the memory location, and it will store in the accumulator. Then after accumulator, the value of the accumulator will be decremented by 1. Then after, the processor again switch overs. So now whatever the value the register or the accumulator have will be stored at that particular memory location. So now it will become, after incremented, it will become 11. Now this process has been wind up. Now the processor will switch over to consumer process, that is the P2 process. Now it has the value 9 in its register, that is the accumulator. Now it will update the value at the memory location, that will be 9. So answer should be here 10, but at present the value will be reflected as a 9. So this is the one of the drawbacks of the shared variable. If two processes are accessing the shared variable simultaneously, so there should be some locking mechanism so that only one process can enter or read the variable at a time. Here the value, the the value at the memory location is depends on the instruction that has executed at the last. Here the process P2's instruction 3, if I am giving the instruction number 1, 2 and 3, so instruction number 3 will execute at the last. So the value of memory location will depends on the instruction of a particular process, that is a P2, that execute at the last. Or we can say the output may also depends on the process order in which it execute, or we can say the instruction that execute at the last. Here counter is equal to register 2 that executed at the last for the process P2. So it is responsible for updating the value of the memory location. So race condition. The race condition occurs when multiple processes or the threads read or write the data item. Final results depends on the order of the execution of the instruction in the multiple process. As I have already told you, the order in which it's execute. Firstly, these two statement execute, then after these two statement execute, then this statement execute, and at the last this statement get executed. So the result will depend on the last statement or the order in which it executes, or we can say this is the loser statement because it executes at the last. So we can say the value will depends on the loser statement. So race condition, according to race condition, the value of a memory location, shared variables memory location will depends on the loser process or the loser statement. Now, when to overcome from this how can we resolve, or we can say how can we resolve the problem. So a program may be categorized into three parts. First one is the non-critical section, second one is the critical section, and again non-critical section. Critical section, for example, a number of users are using the IRCTC website for reserving a seat. There is only one seat. So that can be allocated only to one of the process. So there is a code for reservation, seat reservation, that is known as the critical section. Before that, a number of process can execute its tasks simultaneously. For example, filling up of the name, age, birth, etc. information. But after payment, when the reservation or the seat allocation process will be taken place, that is known as the critical section. And in the critical section, only one process can enter at a time. If more than one process can enter it at a time in the critical section, so seat will be allocated to more than one user. This is not uh, the real life condition. So in the critical section, only one process can enter, and after entering the critical section, it will make the value make the updation, and when it leaves the critical section, it will again perform some action, and then after it will go to the its remainder section. For example, taking the printout, something like that one. It will display the message, your ticket has been booked, your birth number or the seat number is this one, something like that one. So that portion is known as the non-critical section. Not here, the non-critical section portion will be filling up the name, age, mobile number, address, etc. But the seat reservation will be treated as the critical section, and one process can enter into the critical section. So before entering, how to ensure only one process can enter into the critical section? So there should be some entry section, so that according to that the variable can change its variable's value, and when it comes back, it will again reallocate the same value. For example, if this is a class and a faculty want to enter into the critical section, that means class, it will, after entering into the class, it will lock the room or lock the latch, and when he or she will come out from the class, he or she will be open the latch so that another faculty can enter into the critical section. Otherwise, there may be a possibility more than one faculty member may enter into the classroom. This should not be there. So in the critical section, there should be an entry condition and there should be an exit condition. So locking the latch is the entry condition and opening the latch is the exit condition in the real life. So entry section acts as a gateway for the process to enter inside the critical section. It ensures that only one process is present inside the critical section at any time. It does not allow any other process to enter into the critical section if one process is already inside the critical section. Then after critical section, it is the code of segment where process changes the common variable, updates a table, write to a file, and so on. When one process is executing in its critical section, no other process is allowed to enter into the critical section, as we have already discussed. Then after exit section, it acts as a exit gate for the process to leave the critical section. When a process exits from the critical section, some changes are made so that other process can enter into the critical section, as I have discussed. Remainder section is the code of process that is executing in the remaining section. Means, as I have given the example, the railway reservation system, the printing or displaying the information is known as the remainder section. Requirement of the critical section. Only one process can enter into the critical section. If other processes are waiting, if number of processes are waiting to enter into the critical section, only one process is allowed to enter in the critical section, but other process should not suffer from the starvation condition. Means if there is a bulk of process that want to enter into the critical section, allow one of the process into the critical section. It is not, this should not be there. Only one process is entering again and again into the critical section. There should be fairness so that each process will get done and no process will be in the starvation condition. So for critical section problem, there should be three points that should be that should be there, or we can say that are the solution of the critical section problem. First one is the mutual exclusion. As I have already discussed, mutual exclusion dictionary means one process can enter into a critical section at a time. There is no sharing of data. So here four processes are waiting for to enter into the critical section: P1, P2, P3, and P4. Only one process is allowed to enter into the critical section. This should not be the condition कि more than one process are in the critical section at the same time. Second one is the progress. If no process is executing in the critical section and there exists some processes that want to enter into the critical section, so let it be allowed to enter into the critical section. Sorry, it should not wait infinitely. If some process is want to enter into the critical section, it should be allowed it. So can it be possible using the round robin? Means there will be fair selection. First process P1 will go, then P2 will go, then P3, then P4, then after again P1, P2, P3, P4, then again P1, P2. No. Suppose that only P1 and P4 want to enter into the critical section. Why should we wait for the P2 and P3? So round robin is not a optimal solution. This may be a solution if all processes want to enter into the critical section. So progress must be there if some process want to enter into the critical section and there is no process in the critical section. Any one of the process that want to enter into the critical section should be allowed. Last one is the bounded waiting. A bound must exist on the number of times that other processes are allowed to enter the critical section after a process has made a request to enter into the critical section. Means, suppose that there are four processes P1, P2, P3, and P4, and all want to enter into the critical section. So this is not possible. P1 is getting critical section again and again, and the rest P2, P3, P4 are waiting continuously or maybe in the starvation condition. So there should not be the starvation. Here, a process requesting entry into the critical section will get done eventually, and there is a limit how many other process can go first. Means how many times other process can enter into the critical section. Three times, four times, five times. Then after the other process turn must be there. This should not be there. A process is waiting for the infinite amount of time. After five times, six times, seven times, 10 times, 20 times, it must allow another process must allow to enter into the critical section. So there should be a fairness. This was all about the basics of the process synchronization from my side. Thank you.